Okay, so the directions for this one are to use the like bases to solve the exponential equation. So what that means is we have these two exponential equations, and if I have something like 3 to the a equals 3 to the b, the only way that can possibly be true is if a equals b. And that's exactly what we have right here. So since we have 3 to this exponent equals 3 to the exponent, then that means those exponents have got to be equal. Now we have a simple linear equation and we can solve. So at that point, let me bring the x over here and the 6, let me actually go this way. So we'll go plus 4x on both sides. That gives us negative 6 equals 3x, and then divide out and get negative 2 equals x. And if you plug that in there and check, this should come up to negative 2 on both sides. When that doesn't work is when we get a little further into the section, when we have 3 to the negative 4x minus 6 equals 7 to the negative x. That's a whole different problem because now the bases aren't the same, so we can't set those equal. That's the next version of solving. But for these ones where you have a common base, or if you could write it as a common base, so let's say we had 2 to the x plus 3 equals 8, I could write 2 to the x plus 3, 8 I could rewrite as 2 cubed, and now I could set those equal to each other and solve for the x in that. So if you can get a common base, it's great, it works really easy. If you can't, then this is where we're going to need logarithms later in this section.